I will try to make this video in English, but I don't speak English very well, okay? And it's the last time I will explain this. This is a problem, this equation, it's a solution for a problem. A solution for solving the speed of a pair of scissors of any size. So you have a pair of scissors. So you have a pair of scissors here. Opa. And you need to calculate the speed of the scissors closing, the width of the speed, the cutting edge of the speed, right? So the scissor will close and it will run the wide, the cutting edge will run through the edge of the scissor to the, okay. So how do you calculate that? Is essentially with this equation here. But this equation here, it tells me that the end speed is 127.3 c, and this equation shows one more thing. If you pull the scissor in a direction and close at the same time, and the cutting edge in the same direction that you are pulling the scissor, pulling or pushing, I don't know the forward, pushing forward, okay. Yeah, you can take this equation because this is a vector, this is another vector, and you add one vector to another. So this at maximum goes 1c. So if you add one to another, you get 2,273 c. It goes more, okay. And what happens? This equation, it's not wrong, okay. You can calculate this situation here and you will get to this equation. So what's the point? The point is that we only accept that we live in a three-dimensional world, okay? In a three-dimensional world, and this is not completely right, because if we live in a three-dimensional world, we could not get to this equation. Scissors do not have to exist because you couldn't make this equation, understand? Because the three-dimensional world with three-dimensional space dimensionals, with three space dimensions, less of one of time, you can you stay locked to this equation, to this only equation. This equation, it's Lorentz transformation for speed, and you get locked if you live in three dimensions. So you don't get locked, but you can calculate this equation here because it's three-dimensional, right? The scissor is a three-dimensional object, but you violate the laws of physics because you exceed the speed of light. So here comes the next part of the equation. Here's the limit, okay? Limit. this is the Feigenbaum constant, and this is a variable, any variable that means the origin, or the origin of the space, for example. And this is a limit. Uh, it's the constant of Feigenbaum. So what I want to explain in a very rough, very roughly, this equation here is a unidimensional equation. Unidimensional equation, okay? This equation here of the scissors, the second equation, is a two-dimensional equation because it takes angular velocity. It's a double. This constant of Feigenbaum equation is a one-dimensional equation, and the two way you can make it, it's a twin interpretation. It's one-dimensional or two-dimensional. So if you plus everything up, you get 1, 3, 4, 5, 6 dimensional. So the space, and I will explain why soon. So the space has 5 or 6 dimensionals, spatial dimensions, because when you suppress the speed of light as it here, or with here, with the add of one and the second equation, you have to take the space, you have to take the space from another place, another three-dimensional space, and bring to this three-dimensional, to our three-dimensional space, because our three-dimensional space has laws, and the laws said that we cannot suppress the speed of light. But if you have something that exceeds the speed of light inside of three-dimensional space, you have to take the space from another place. And what is this place? It's exactly this limit, this constant of Feigenbaum plus multiply by the origin. That's the basic of the basic explanation of this equation, and I will change her from place. That's the basic explanation of this equation. So what happens if you have more dimensions than three-dimensional space? You have something like, imagine that a cube has is made of six squares, okay? 6 do these squares. So a cube, one cube is 6 to the squares. A 4-dimensional, a 4D cube or hypercube, it's some sort of a lot of 3D cubes. And a 5-dimensional cube is some sort a lot of 4D cubes that are a lot of 3D cubes. So that's the point, that you must think about it. And it's a doubt that I have, and I'm sharing with this equation. Thus, each cube of this high dimensional structure are a timeline sequence. That's the point. If we consider that each cube of this 4D structure of this, or this 5D or 6D structure, is each 3D cube is a sequence of time, then we have timelines. Timelines and and we don't have time paradoxes. We don't have any time paradoxes because each cube is a copy of our cube, or our cube is a copy of another cube from a time minus one, for example. And that's it. That's the last time I made this video trying to explain this for everybody, and I hope I could lend some inspiration for someone. Thank you.